Okay, suppose that a tube was sealed containing HI at a concentration of 0. So the initial concentration of HI, it's equal to 0.002,000 moles per liter. And it says given a K of 54.4 at 425 degrees Celsius. Now the temperature here is not important. Later we'll see for endo and exo how the K changes, because you know that the reaction in the K of the forward and reverse reaction is going to change with temperature. The K changes with temperature. Remember, this K is for the forward and reverse reaction, but we need to consider the kinetics. I'll explain that when we get there. For the equilibrium, so the temperature is just giving you a data. There's no change in temperature. So they give you the K for an equilibrium described below. Calculate the equilibrium concentration of all species present. So they're asking for, the question is, okay, what is the concentration of all the species in equilibrium? Concentration of H2, concentration of I2 of iodine, hydrogen, and the concentration of hydrogen iodide. Now, they're only giving me the initial concentration of HI, hydrogen iodide. So that means that the only concentration initially that we have is 0.02,000. Let's do, right, the ICE so we can determine the concentration in equilibrium. So here the concentration of HI is 0.2000. Where do you think it's gonna, how the equilibrium is going to shift where? To the left. You're going to produce H2 and I2 because you started with HI and you're going to be producing H2. It goes on the reverse side. It goes from right to left until it reaches the equilibrium, until it reaches H2HI and H2 I2 reach a concentration in which all the system is going to be in equilibrium. So initially we have 0. So if it's going to the left, right? If it's going to the left, the and it's important to know this, right? If it's going to the left, then this, right, is going to be the change minus 2x because the coefficient is 2. The concentration is x and the concentration is x. This is the stoichiometry. For every mole of I2 that you use, you're going to produce 2. Okay, 2 moles of HI. So the equilibrium is going to be 0.02000 plus the change, which is minus 2x. And here, x, 0 plus x, and 0 plus x. So let's write the expression for the equilibrium. And it's going to be the concentration of HI to the square divided by the concentration of reactant, which is going to be the concentration of H2 multiplied by the concentration of I2. The concentration of both H2 and I2 are identical and are equal to X. And up is going to be the concentration of 0.02 thousand minus 2x to the square. And here would be x multiplied by x. Let's plug in our values, the k value, and it's gonna be, the k is gonna be 54.4, right? Here it is, 54.4. Let's plug it in here. Equals 0.02000 minus 2x to the square divided by x to the square. Now, looking at this real quick, you're going to have the tendency to solve for this, solve the quadratic equation, and this is so simple because if you do this, if you get the square root of 54.4 right on the left, and on the right side, the whole square root, right, of 0 to eliminate the exponentials. This is a division, so it would be, if it's a division, you can do that with the square root, right? The square root of 54.4 equals the square root of 0.02 because the square is the exponential is squaring the whole expression. So you leave it outside, divided by the square root of x squared. So you can cancel out the square root of something to the power of 2. So the square root of 54.4 is equal to 0.02000 minus x divided by x. Now the square root of 54.4 is 7.38. Now we multiply x both sides by x, or we get it up, equals 7.38. I was thinking about something and I said something and I wrote something different. Hold on. 38x. Okay, we multiply this by x, and 0.02123 minus x. So this is going to give you, if we add x on both sides, it would be 7.38 plus 1, and this is multiply everything by x, equals 0.0200. So x would be equal, this is 838. 838. So it's 0.02123 divided by 8.38. Let me do this calculation because it's not done by steps. So it's going to be 0.00238 I know this is minus 2x when I copy it. This is minus 2x. So this would be 2x here. Sorry for that. When I copy it here, do you see it's 2x? Oh no, hold on. So this is gonna be, minus 2x, identical, but it's minus 2x, and it's 7.38, and we got this up, x, so this would be 7.38 plus 2 instead of 1, so it's gonna be 9.38. So this x is gonna be equal to 0.02 divided by 9.38 equals 0. It's 2.13 by 10 to the 1, 2, and 3 by 10 to the minus 3. Moles per liter, of course, is concentration. So if we subtract, remember now we have to calculate, this is the concentration of hydrogen and iodine is X. Now let's calculate the concentration of HI, which is 0.02 minus twice this value, the value of X. So first, the concentration of HI, H2, is going to be equal to the concentration of I2 equals 2.13 by 10 to the minus 3 moles per liter. Now the concentration of HI would be, if you remember well that I got it up, 0.02, here it is, minus 2000 minus 2x, but x is 2.13 by 10 to the minus 3. So this would be, the concentration of HI would be equal to 0.02000 minus 624, and minus 3 would be 1, 2, 3. No, hold on. 4 minus 3. 1, 2, 3. 1, 2, 3. Yeah, I miss a 0 here. It's 1, 2, 3 minus 0.1246. I put it in, I moved the decimals 3 spaces to the left and I multiply already by 2. And this gives me, right, gives me 0. Okay, hold on. 0.02 minus 0.00426 equals 0.01574. So the concentration of HI, let me put it a little bit higher so you can see it better. HI would be equal to 0.01574 moles per liter. Now let's go to the next one. The next one would be, okay, the equilibrium K for the reaction of hydrogen plus CO2 gives me water plus CO. Number 8, we did it in class. It's the did it in last lecture. Okay, it was done last lecture. Remember that it was after reaching the equilibrium. It was part A and part B. What is the concentration in moles of each substance in equilibrium? The only difference is that they're giving you the constant, right? Then part B, you see if additional CO2 is introduced into the equilibrium system, but it doesn't say the concentration. Yes, it's basically identical to the other one we did. But the part B doesn't have numbers. Let me solve it. Okay, let me solve it because it's very similar to that, but it's not identical. So we have here, okay, we have here that the equilibrium constant for the reaction, of course at a certain temperature, they have to put it because it changes with temperature, but in our reaction it's not going to change, you see. If 0.5 moles of hydrogen and 1 moles of carbon dioxide, what is that? Read. Those are placed in a 2-liter container that is held at a temperature of 700. What is the concentration of each substance in equilibrium? So basically, they're giving you the initial concentration of hydrogen and the initial concentration of CO2. And these are of hydrogen would be 1.0 moles. Now this is moles. What do you have to do? Divide it by 2 liters to get the concentration. Do you see? This is the moles. 1 mole in 2 liters, 0.50 in 2 liters. And by the way, if the hydrogen is 0.5 and the CO2 is 1, let me double check before I write like crazy something. I write things without thinking. If 0.5 moles of hydrogen, yes, it's 0.5. You see, I was not thinking what I was writing. Sorry for that. Moles over 2 liters. So this is going to be 0.25 moles per liter. Already the concentration, and this is going to be 0.5 moles per liter. Now they're asking for all the moles per liter. They're asking for all equilibrium concentration. Let me write down what are they asking for. Concentration of H2 in equilibrium concentration of CO2 in equilibrium. No, it's not equal. Hold on. Well, yeah, it's going to result equal, but and concentration, this is what they're asking for, and the concentration of H2O and CO, all of them, okay, in equilibrium, and the concentration of CO in equilibrium. So we got here, right? What is the concentration in moles per liter of each substance in equilibrium? Let's write the equation, very similar to the other one. It's H2 gas. H2 gas. Let not go back and forward. I have the problem here. Plus CO2 gas in equilibrium with H2O gas plus water gas plus CO. It says CO. So now you got here, it doesn't matter, it should be gas too. So now we got here H2, right? Initial concentration is 0.25, 0.5, and this is the initial, the ICE. What is going to be the change? Of course, if you have 0 and 0 here, they're just giving you the two reactants. It's going to go to the right. So you would have the change would be 0.20. Let's put the change, sorry. It's going to be minus X here. Minus X because it's forming products. How much water? X. And how much CO? X. So what would be in equilibrium? It would be equilibrium, ICE, would be 0.25 minus X. 0.5 minus X. X and X because you add them. So let's go ahead and write the expression for the equilibrium. And it's going to be water, okay? You have the problem with you. What I'm going to do is I'm going to plug in the value without going up on the screen. Here is going to be, but let me show you the equation so we can go. It's going to be CO, right, divided by the concentration of hydrogen multiplied by the concentration of CO2. So now let's plug in our values, and as I said, I'm not going back, but I'll give you the values, and this that is more important. What is the value? You see your problem. It's given, the K is given 0 point at this temperature 771 equals what? What is the concentration of water in equilibrium? X, right? X. What is the concentration of CO? X2. If you look at here, what is the concentration? This is hydrogen. Of hydrogen would be 0.25 minus X, and the other one is 0.5 minus X. Um, and 0.5 minus X, 50. So we're going to do 0.771, okay, equals X squared. Well, we do the distributive property, so it's going to be 0.25 by 0.50 minus 0.25x minus 0.50x plus x squared. Right? It's first one with first one with second one with first, and second one with second one. And this is so it would be 0.771 equals zero x squared equals x squared divided by, if you do this, it's not done in steps. So it's gonna be 0.25 multiplied by 50. That's 0.125, right? Minus, this is negative and negative, right? So it's gonna be minus 0.75x plus x squared. And this we multiply. Now let's multiply everything by 0.71. So we get this up, and it was 0.771 multiplied by 0.125 minus 0.75x plus x squared, right, is equal to x squared. Now this is gonna be 0.125 multiplied by 0.771 equals 0.092. Yeah, 96. 0.096. I don't know if I have something wrong. Minus 0.75 by 0.771 is 0.57, 0.5783, right? Plus 0.771x equal x squared equals x squared. So let's go ahead and pass it to the right. So everything here on the left is 0. So it's gonna be x squared is going to be 1 minus 0.771 x squared. And this has an x, sorry, plus 0.5783x minus 0.096. So this is going to be 0 equals 0.23 square root plus 0.5783 or 58 minus 0.096. So if we do this, x equals to minus b, which is 0. Minus 0.5783 plus minus or 58. Let's take it to 58. We can do that. 58 plus minus 0.58 to the square minus 4ac, but ac is negative. Well, let me 4 by 0.23 multiply by 0.096 divide everything by 0.23 by 2. So x is going to be equal to minus 0.58 plus minus and 0.58 to the square is 0.25. Let me see, 0.58 to the square is 0.33, 0.3364. Now this is negative, so negative and negative is positive. So we got 0.096 by 4 by 0.023 equals, the most you can get is something like that. So it's gonna be 4 by 0.23 by 0.096 equals 0.088. Now there's not too many 832. There's not too many decimals, so we can do it normally. We add them now, plus 0.3364, and we get the square root. And this divided, we multiply these two, is 0.46. So x will be equal to minus 0.58 plus minus 0, the square root of 0.442, oops, 42472 divided by 0.46. And this gives me that x equals square root of this minus 0. Oops. Hold on. 0.42472 is 0.65. So 0.58 plus minus 0.6517 divided by 0.46. Now you know the negative value. Negative and negative, you have to cancel it out. So it's going to be, and it makes no sense because if you put a negative value, then the concentration would, you have to add x instead of subtracting. So this is going to be 0.65, right? Minus 0.58 plus 0.65 divided in by 0.46. Let's say this is x2. x1 here that you're going to eliminate is minus 0.58. You have to be able to choose, and you see this is not a long problem. Minus 0.65 divided by 0.46. So here we got x2 is gonna be 0.58 minus divided by 0.46. It gives you 0.175 moles per liter. Now, if you look back, we got that the concentration, let's look back, the concentration of hydrogen was 0.25 minus X in equilibrium CO2 minus X, X and X. So what is the concentration of the products? The concentration of the product would be the concentration of H2O, right, equals 0, the value we got X, which is 0.75 moles per liter. The concentration of CO, another product, would be X, and it would be 0.175 moles. Now the concentration of hydrogen was, if you remember, that I said it's 0.25 minus 0.175. And by the way, this is moles per liter and this is moles per liter. So it's 0.25 minus 0.175. It's equal to 0.075. 0.075 moles per liter. And the concentration of CO2, that's the other reactant or the one on the left side, is 0.5 minus 0.175, and it's equal 0.32. 325 or 0.33 moles per liter. Now on the homework answers, when you see it, this is gonna give you, because there's a little bit of different. I don't know if I did it wrong or what, but when you get this term, this on the homework is 9.2 something. So then don't get caught up in a simple decimal thing. Honestly, it is a simple because the procedure is perfect, and how I said, I'm not gonna evaluate because you put a decimal at the end. You have to give me the right amount of sig figs. But in the other ones, if you put a 5 in your calculator, but the most important thing are how to present the problem, that the math is not so crazy, and meaning that that's the way of doing it, quadratic equation, that you have to choose the right value when you get the 2x, and that the results, it's a matter of, the homework says 0.36. It's 0.03 of different. So those kind of errors are not really important. And basically, I would ask a lot about concept questions, that we have some of them in the homework too. So let's do part B. If an additional mole of CO2 is introduced into equilibrium, described in A, and the system is then allowed to again reach equilibrium, what would be the resulting concentration of the reactant and product? Now this is not even, you see, this is a concept questions. You add additional mole. You're adding 1 mole of CO2. Yeah, you're adding 1 mole of CO2. And in the on the concentration, we did this very similar, but let me show you. When we had here this, right? We had 1 mole and the volume was 2 liters. So let's go ahead and know that we have as initial now the equilibrium concentration were the initial. So what is we're going to have? Let me write the reaction again. H2 plus CO2 gives me H2O plus water. Okay, plus CO. Water plus CO. Now, you had in equilibrium, you had 0.075. You had 0.33. Remember this? By the way, this stays the same. It's rounding. If you round something with 50, what I don't remember, yes, this is 000. Hold on. This is 000. If you drop all these three and this is odd and this is even, it stays the same. So this is 0.32. Yeah, I forgot what it comes after the 5. Okay, so this would be 0.32, right? These are the equilibrium concentration in the equilibrium on part A. But now you're going to alter the equilibrium. How? Adding 1 mole of CO2. So now you got here, right? What was the concentration of that was X. Remember 0.75, 0.175 of water, 0.175 and 0.175. Now we're going to alter the equilibrium. So this is the initial concentration for the new equilibrium. And what would be the change? The change would be now a new concentration here. We're gonna add 1 mole, but remember it's 1 mole. So the concentration now of CO2 would be because this is the initial, but we add 1 mole of CO2 and then the equilibrium. Okay, now the equilibrium is altered and now it's gonna try to reach the equilibrium back again to reestablish. So CO2, we got 0.32, right? Hold on. 0.32 plus 1 mole, but 1 mole, right? But it's 1 mole and it's 2 liters. So how much is gonna be? It's gonna be, you add how much? CO2 would be equal to 1 mole divided by 2 liters is 2 plus 0.05 and all these moles per liter. So this would be 0.82. So instead of writing this, because this is going to be the additional, or we can write 0.5. Okay, now this is 0.82. Now this is the initial concentration. Now let's think, if we add here, where is the equilibrium going now? How is it going to shift? It's going to go to the right. Why? Because we increase the concentration of reaction, and to compensate the equilibrium and the addition of reactant is going to produce more products. So if we have this, right, we're going to produce X, this would be minus X, and this would be minus X. So the new concentration in equilibrium would be 0.075 minus X. This would be 0.82, 0.82 minus X. And this would be X, and this would be X. So here we got Let's write the new, because it has to keep the same k, which was 0.771, if you remember. So again, the expression would be the concentration of water multiplied by the concentration of CO, okay, divided by the concentration of H2 multiplied by the concentration of CO2. So let's plug in our x's and the constant, equilibrium constant. So it's 0.771 equal. What is the concentration of water now? X, and the CO, X. Now what would be the concentration of H2? 0.075. Look at minus X, right? Look it up here. And 0.82 minus X. Multiply by 0.82 minus X. So this would be 0.771 X squared. Now let's do again. 0.075 multiplied by 0.82 minus 0.075x minus 0.82x plus x squared. Now we're going to multiply everything by 0.071. So let's start. 771 multiplied by 0.075 multiply. I'm cross multiplying again. 0.82. This is not an x. This is a multiplication. Minus. Now it's going to be, let's add these two. By the way, this is going to be minus 0.771, and we multiply by 0.075 0.075 plus 8.82 equals 0.89. So this is 0.89. It would be negative, but I put the negative already here. X, all this x, and then here 0 minus 0, no, this is plus, I'm sorry, because it's minus and minus. No, so it's okay, sorry. Plus, yeah, but I forgot to put the plus here, plus 0.771 x squared equals x squared. Again, we take it all to the right and we equal this side to 0. And it's going to be 0, okay? And let's do this. 0.771 multiplied by 0.075 multiplied by 0.82 equals 0.0474. Now this, okay, if we took this to the right, this is 0 equals minus, this has a negative sign, this would have a positive. 0.0671 multiplied by 0.89 equals 0.6862. And by the way, you can do it yourself and then see my results and compare it. And then ask me any question. So now this goes negative, so on the right side we have 1x, so it would be 1 minus 0.75, which is plus 1 minus 0.771 equals 0.229x squared. So solving this quadratic equation, right, it's gonna be, again, let me rewrite it better, 0.229x squared plus 0.6862x minus 0.0474 equals 0, or 0 equals all this. So x would be equal to minus 0.6862 minus, I wonder who invented math, minus b squared, hold on first, 62 squared minus 4ac, and a is gonna be 4 multiplied by 0.229 by 0.0474 divided by twice, and the value of a is 0.229. So now x would be equal, I'm going to solve everything that it's on the square root. Okay, well, it's going to be 0.6862. Here is going to be 0.4709 minus and minus plus, because this is negative, as you see. The c is negative. Again, I forgot to write it down. So it's going to be plus 0.0474 by 0.229 by 4 equals 0.0. Just double check my math. By, I think, hold on, 4 by 0.229 by 0.0474 equals 0.0434 plus 0.4709 is 0.51. Hold on, before I write this, this is 18.54 down here, and here would be x equals minus 0.682 plus minus the square root of 0.5143 divided by 0.458. 0.5143 equals 0.75. So x would be minus 0.6. Again, we have to use the positive. Forget about it. Plus 0.7171, because if we use negative, we get a negative number. Divided by 0.458. So minus 0.682 divided by 0.458. So x equals 0.0767. 0.077 moles per liter. Now let's go ahead and plug it in our value, because that is only x. So the concentration of H2O and CO is x. The concentration of CO 0.82 minus x. So if we got, right, let me write it down. Just remember this number. The concentration of water equals the concentration of CO equals the value of X, which is 0.77, 0.077 moles per liter. The concentration now of CO2, remember it was the concentration of CO2 was 0.82. I don't know if you remember that, minus 0.077 equals I think I got something wrong. Oh, what was wrong, for God's sake? Let me put a pause and let me check my arrow, okay? I'm going to check my arrow for a second. I'm going to put a pause.